Welcome to a new test and teardown video. This time it is something completely different. I really hope you're going to find this one funny. Oh, I know I am. So this one is a Venner electronics from England. Frequency and time measurement unit TSA3436. This design is from 1969. So just wait a second. Look at the 6-digit readout. Can you figure out right now what kind of type of readout this is? I really think you should just pause the video, think a little bit. When you're done thinking, then continue and let's see if you were right. Please comment if you could guess what kind of display type this is, just by looking at it like this, because I guessed wrong. I bought this unit from a flea market quite a while ago, and now I'm gonna go play with it. This is going to be one long, fantastic night. I can't power it up right now because it's full of some loose items. I'll show you the back, and then you're probably gonna guess what is going on here. The back side of the unit is one big surprise at the first look of it. There's a really nice label. Oh, sorry about that. It shows here the serial number, the type. 32 watts. Interesting. And again, this is 1969 design, right? We've got gate control, external or internal. Crystal reference can be external. It's a little bit annoying they don't say what kind of frequency the crystal level is. Maybe you're supposed to read the manual, right? Probably got some adjustments for crystal here. It can run off mains, or you can run off external DC, 12 volt, 1.8 amps. Disconnect. So here is the clue for the readout technology. We got some set 0 for all the 6 individual digits. This is a linear adjustment for the set 0, and also set 9 linear pot meter adjustment. So there's something we need to switch to manual, press and release reset 9, or disconnect signal before adjusting. So there's some interesting stuff here that needs to be adjusted. I bet you have now figured out what kind of readout technology are we talking about. If you haven't yet figured this out, maybe we should continue. Let's look a little bit inside and let's reveal the readout technology. So those digits are actually projection. So here we got a lamp. So there's one lamp in here. It's all the way in the end here. You can see the lamp is down here at the very, very bottom. I don't know if you can see that. No, it's not super clear. But I do expect, I really hope that I'll be able to take apart one of them to show you how this is built. And then there's a moving coil. You can even read the brand name, EAC Digivisor Mark II. So the moving coil needs 0.25 milliamps and the lamp is 12 volt. So this works, but there's a little lamp and some optics, and then there is a round disc with all the numbers, and this is rotating with the moving coil milliamps. So it rotates the readout And that is probably going to look super, super nice. And this is why you have this analog adjustment of all those 12 potentiometers, the Z0 and the Z9. That is, of course, you want to align all the moving coils. I think you did figure this out when I showed you the zeroing potentiometers, right? I've just been mounting this one a little bit better because the screw was loose, and of course there is a power on switch at the end of this multi-deck switch for all the different frequencies and stuff like that. Sensitivity, AC or DC. I've also been lubricating and cleaning. This one was like really difficult to move. It's still a little bit funky. It's, yeah, definitely from 1969. I totally remember those capacitors from when I was a kid with the black and red ends. Those are cool. And this is, of course, all low voltage. There isn't any high voltage stuff here because it's just 12 volts for the bulbs and everything else is just low voltage kind of stuff, right? Mains transformer, and it is connected for 225. So that means I should be able to power this up. I only found one loose screw in here, and I don't know where it's supposed to go. So maybe somebody dropped a screw in here. I don't see any leaked capacitors or anything really bad. This looks a little bit funny, but I mean, it's all okay. What was supposed to be in that socket? I got no clue. Maybe that will be 2 spare bulbs. Could you imagine just sticking them in here so they are available when you unscrew this and just put in a new bulb? That could be a nice way to do it. I believe that will be selenium rectifiers. 2 bridge rectifiers, selenium, on this piece of aluminium. And that will just be all the counters and stuff. This is just more or less normal technology. I don't know what you call it. Full of transistors and such. Quite beautiful the way this was made. So imagine this thing is counting like a frequency counter, and then it needs to convert each of the different digits to an analog voltage that goes to the analog readout. I mean, that is just absolutely amazing. I can't remember ever owning anything like this before, so this is a new kind of readout technology for me, and I already think about, ooh, if this doesn't work, I definitely want to build a clock out of those 6 digits, because it's gonna look so cool when it's running like that all the way up and then start. I don't know, that's probably going to look absolutely cool. I really hope the mechanics work here. So we got, it's actually reading, what is this? Yeah, that's just the company name. We got some different test points. Oh yeah, we got, that one is nice, right? So this is the oven. Imagine that. Is that really necessary? How can this do milliseconds, microseconds? Okay, 1 microsecond. Okay, so that makes a little bit of sense, right? And frequency times 10. We got that many digits. Can it really go? How fast can this thing go? And I don't know what that is. Probably some, I don't know, you can measure this and that. What is the idea here, really? Oh yeah, look at the crystal. So we got this high impedance feed line here, right? That goes to the oscillator circuit here. And for some reason they cut out in this PCB. And this is of course the fine adjustment for the oscillator. And so this is an oven. And what you can do is you can pull up the oven circuit here. So there's a temperature switch and a heater in here, and it's regulated for 75. Well, that's just amazing. And this crystal is 1000 kilocycles, so that is 1 megahertz, right? So that's probably also the input and output on the rear here. So I can't wait. Let's just stop talking, okay? We need to power this up. Let's do this together if you're ready. Are you ready? This is off. Just crank on mains and see nothing happens. 2.2 watts. Sucks. Where's all the fancy stuff? So what do I do? This is in test, right? Oh, come on, man. So we got some reset 0 auto lotta yada lotta. We're missing some voltages, right? Probably those dodgy selenium rectifiers. So I'll now go and googly around and see if I can find any kind of schematics or whatever. Oh, come on, you stupid. Yeah, that sucks. Is there anything on the back that I missed? I'm just a big idiot. Remember, on the back there was a switch between 12 volt or mains. I left it in 12 volt. So I definitely hope something is gonna happen now. Okay, let's see. Ooh la 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 la. How do you like that? Now you know what I'm saying? Oh, that is nice. So something is definitely happening. So test. How do I? So there's a 0, right? So I push. Well, how do I operate this thing? We need some light in that one. Oh, but it's alive. 31 watts. That is what you got. Oh, we got some. I just want to sit and look at this for a little while. Don't you just love it already? I am totally in love. So it's counting something. Wow, manna. What is going on? I was expecting this test to do something. Reset 9. Ah, so that is what happens. So it was supposed to show 9 here, right? So I hold this, see? Ah, haba. So the top one was the 9, right? Yes, see? So I have to. No, that was probably the 0. I'm an idiot. So that's 9. Okay, so the top one here is 9. Good. This one is 9. Okay. So how do I make it 0? Set 0. Ah, so I hold the 0 down now. How do I make it go 0? That is one big. It looks like I need. There's some kind of funkiness going on, right? So this is now. Why don't I have a manual? What is going on here? I've been playing around with adjusting the minimum and maximum, the 0 and the 9, and I was more or less lucky to go half the way here to do all that. And then I heard a bang, and then the power consumption went from 30 watts to 110 watts. And now the light is all dim. Oh no! I was about to be happy and then something bad happened. As always, I'm just doing my little dirty trick here with the thermal camera. And look down here. There's a capacitor that is burning hot. That one down there. The silver one is burning hot. And of course also this rectifier is very warm. Selenium rectifiers that's getting hot and saying kaboom. No, not good. What else have we got? What is down there? Of course the oven is burning hot, right? So that was supposed to be 75. So that is something we expected. But when I browse around here for anything else, I don't see anything. Of course that's will be all the bulbs down here, and that one was without any light. I really don't like kaboom sounds. I don't have any smoke though, but oy. Yeah, this is not normal. You don't want those rectifiers to be that warm, and certainly not capacitors down there. So I need to dig my way down there and probably change both of those rectifiers, and anyway also go and see if I can change that lamp. Now I know exactly why we didn't have any light in the first digit here, and that's because the lamp is missing. And of course if you're missing lamps, what you do is you put them in all the digits to the right and not the one to the left. I mean, that's a pretty good way to do it. And here on each digit it only says 12 volts and not a lot more, right? But on the old bulbs I see 2.2 watts or something like that, right? But when I power this up with 12 volt, it uses 2 watts. So this is what I'm aiming for. Let's go and find another one. I think that I will call that a little celebration for tonight. Don't you just love it? I think that is one of the most sexiest readout technologies you can imagine. I'm so sorry this is not shown on the video. I should probably do a high speed, but you can imagine those are actually real moving dials with optics and all that projection kind of stuff. So it looks absolutely amazing. The blanking here is to blank it while it's doing the count, so you're not getting confused on the count. You can see it's like that, right? And then it shows. So this is actually 1, 2, 3, 4 hertz that I'm inputting. And if you count a lot faster, like this, then the blanking should be, of course, a lot. No, I'm of course counting 10 times as long, right? Oh, bugger. Yeah, okay, then I get one more digit. No, that's not what I wanted. I want to count 10 times as fast. So the blank should be, yes, that is exactly what I wanted. So now the blanking is really, really fast. And then I get much more readout time. That's quite nice. So this is 1 second. And then the next cycle, it's gonna show me the result. I mean, I totally love it. You can of course change the display time here, and if you don't want that much display time, you want to go as fast as you can, then it's like that. And over here, super fast, but of course now it's 10 hertz resolution, right? I'm totally in love with this machine, I must say. So now I need to go and find some new bulbs. There was another one that stopped working while I was playing with it. try to clean everything here and make it work again. I also like the way that you're adjusting the focus or the position of the bulb up and down with that screw here, and that actually helps a lot. Let me show you this. So now I go maximum hold, so now we're not going to get confused, right? So let's look at that number 1 right there, right? See, if I move the bulb, you can see what's going on here. You cannot see anything now. See, this is not good, right? Then I can move it down like that, so it's quite all right. I also tried to change the little optics down there. There's a little lens behind the bulb, and I don't know if you can see it on the video here, but I feel that number 2 is a little bit more bright, and that is because I cleaned it when I replaced this bulb. So I'm going to do that with all the others as well. By the way, the problem, there was actually a little shiny capacitor down there, that one, but it is not just a capacitor like that. This is for mains input filtration, so that capacitor actually goes straight to the power switch mains, and there's probably something wrong with that capacitor. What I did is I just cut away the 2 wires because it is just parallel to mains input, and I kind of don't want any capacitors on live input, especially when it's old leaky stuff that is not doing any good. And now my current consumption is down to 28 watts, and everybody's happy again. No more funky kaboom sounds, and it was so close to having this capacitor blow up and smear all its guts all over the place. But I was so fast when I heard something, and I just cranked it off. But there was definitely a poof kind of kaboom, not like a real bang, but something was definitely going on that was not supposed to do its thing here. So yeah, hopefully I can find some more bulbs tomorrow. So it is a nice new day, and of course I got some bulbs, and those are, I believe, exactly the same rating, because 12 volt 170 milliamps should be exactly the same as the other bulbs. But is there a problem here? If you look at the filament to the right, that is the new one, you see it goes up and down, and the one to the left that is broken, that is the old one, and that goes just straight left and right. I think actually the one to the right here is better, because I think it will distribute the light over the digits better. So now I'll put in 2 of these and see if that is better, and compare them side by side with the other ones. So I'll put the 2 new ones in the 2 digits to the left, and then I'll see how that looks. So I believe I have solved everything here. It is working really good again, and you can see here I'm using the 10 Hertz count time, so it's visible to see the counting here. The input is about 12 kilohertz, and in 10 Hertz, of course, you don't see the first one, so it's 1, 2, and then 3, 4, 5, 6, 0 should be the correct readout in this mode, but it's reading 4 Hertz too much. So that is it. Also, how I believe this unit is working, I believe that we have all the different counters. There are, of course, binary digital counters made using flip-flops, but then you have some resistors from each of the counters that makes a DA converter. So the output is an analog voltage that goes from 0 to 9, and that voltage drives each of the displays moving coil readout part of it, right? So this is why you can see when it is counting, when the frequency is very high, see you have about the middle value, and here you can even see the ripple, and here you can see it's able to actually move to that counting update frequency And so that means the instrument is making like a low pass filter, and this is what you see here. You see a little bit of ripple, and here you can respond, and here is of course nice and stable. So that actually completely reveals how this instrument is made. And if we go in ×1, of course it's either going to read out 6 or 7 because it is reading a little bit too high. So this is how you see this. What I can do is I can actually input a frequency that is a little bit too low. So this is what I will do here, and then I've compensated for the problem, and now I should be more or less always hitting 6. We'll see if that is the case. Yeah, exactly. And if we are in a hurry, we can do it like this. Oh, it's because I have quite a lot of display time. So that's my 12 kilohertz, and here we can go down a little bit and see when will I get a number 5 there all the time. Really? Maybe I should try and adjust the oscillator frequency. There's a little bit of a skew in the different settings here, so maybe there's a gate that's not super sharp with the gating, because there's of course a gate, a gating divider. So look at that. Now I've gone all the way down here, so let's see. And yeah, you see, I am that low. I'm way too low. So that is revealed. So that's actually quite interesting to see how this is made. So there's a, I don't know, maybe a rise time, fall time, gate counter kind of issue. It turns out the entire display section is hinged back here. So what I could do is I removed all the 4 screws here and also the front panel, so I could bend out the front panel and this way make room for the display to rotate in the hinge. And I think the idea is that I should be able to unscrew those 2 brackets and probably take out the front plastic and clean it and stuff like that. But my intention here is actually to try and see if I can get inside one of the readout modules. Oh, there's another little circuit board hidden down here, and it looks like it's a power supply with a big TO3 transistor and some other transistors and stuff. So I am getting more and more inside. Let me see if I can turn on some light here. I believe the front glass here is where the magic happens. See, it's made on the back side, and that is of course the side that goes towards the projection, and it is shining the light directly on this piece of plastic, and that is why how it creates the image. What we can see here is we can see the moving coil in here, and we can see the little, yes, here we go, that is the optics where the picture comes out from. So the picture is really tiny. Probably there's a rotating disc on the back side of this magnet thingy, and we got a lot of nasty dirty fingers on the glass here. So that sounds like glass. I was hoping to get all the way in here. Yes, and by the way, I figured out something that is not really explained anywhere else. On the internet, there's another guy talking a little bit about this unit. He's writing something on a web page, and he thinks that the wires that we see up here is supposed to short the coil for transport, but that is not the case. Those 2 wires, they go to the bulbs, so that will be decimal point dots, bulbs, and they're down there, and they are not connected to anything in this unit. And that's actually a little bit of a shame, because like I previously shown with the different indications here, it could be really, really smart to have a dot, you know, when you move the resolution and move the digits. I mean, why not? That could be really, really nice, helpful feature, right? But they just didn't implement any of that. So, of course, the user know a little bit about what this means. And if this is times 1, I mean, this is 1 hertz. So, obviously, it should be quite clear what you're doing. But when you're poking around in microseconds and milliseconds, it is probably not that simple what it is you're doing. So, I mean, that's a little bit of a shame that they didn't do that. So this is the bottom view here. I think with a little bit of luck, I should be able to go down here and remove the 4 wires to the most left digit. As you see here, that will be the 2 wires for the meter. And the blue and the red, that will be the wires for all the bulbs. Those are just all in parallel. Oh, by the way, every bulb here is 2.2 watts. And we got 6 of them. So that's 13 watts in total just for the bulbs. And I must say that the entire back end here actually gets really, really warm when you're playing around with this for quite a while. So adding an LED could be a good idea. But of course, you're not going to create the same vintage kind of feel to it. So that took a little while to take that unit out. So here we go. The nice EAZ Digi Visor Mark II projection readout. So my idea is I'll see if I can get in here without causing any kind of damage to anything here. And it looks like we got so this outer case here is in 1 unit, right? Yes, that is extruded piece of metal. So that means the only way to get in is to remove those 4 screws here and pull out the front. And the 4 screws here, that will pull out the back. We already seen the rear side here, so that is where the bulb and the bulb position adjustment is. And that will be, yes, you can even see the little optical here. So there's a lens that picks up the light. Yeah, let's just try and disassemble this thing a little bit. Let's just take away the front first. And the fun thing is, I took out the 4 screws here and they're not the same length. Well, one is a lot longer than the others. Isn't that funny? And by the way, look at that big nasty fingerprint. You can probably even read the fingerprint that's here on the back. That is some funny thing. I thought the case was, I don't know what I thought, but it's Bakelite. And that is a little bit untraditional for that type of shape. And yes, it was indeed a little bulb here for the decimal point. So that is what those wires are doing. And the glass is just glued in. And here, yes, we see the meter can move nice and freely. And down here we got the little optical fantastic thing that creates the image. That up here is probably the alignment of the coil, right? Coil zeroing is down here. So there's another little plastic thing here you can remove, and then you'll access a tiny little screw down here. And I believe that together with that spring down here moves the entire projection up and down. This way you can align, because we've got 6 digits on a line, right? And you really want the same height on all the digits. So that is what you do. Here is height alignment. So now we already know exactly what everything here is doing. And I think that we cannot take out everything here. So I really want to take away the bottom part I just want to know if that is safe. Yeah, you see what I was worrying about. So we got the coil connection here, we got some other screws here for some optical, and inside I got some wires that goes all the way up here to coil stuff. So that means if I take away the bottom part and just pull, I could damage some stuff, but I hope the wires, they are long enough for me to be able to desolder the wires, and then probably I should be able to do it, because you don't know how this was assembled. Maybe they did it the other way around, right? So maybe this was in first and then they put in all the optical stuff. So that is what I'm a little bit worried about. I think it's a very, very good style to think a lot and act a little bit slow when you're working with stuff like this, because you can easily cause permanent damage to super, super rare items like this. Let's just enjoy the glory of the business end. Oh, that is nice. So yes, I was able to pull the entire thing out, but that was a little bit tricky because there was a spring, and this spring just goes on the bottom of the case. So that prevented me from pulling it out, so I needed to lift the spring. And also, all those 4 screws here on each side, they are very, very loose. One of them was almost all the way out. And that is of course because you want this entire unit to be able to be adjusted with that spring. So they were just very, very loose, and they didn't secure them with a tiny little drop of glue. So you can see there are little spring-loaded screws. So that is something for maintenance here that you need to worry about. And you can see the meter is freely moving down there. It's actually a very, very good, high quality meter design. Very big, good coil. So I totally love the way that everything here is made. And that is all the optical stuff that takes the light and make it go all the way to this little readout. So the readout thing is about 45 degrees of a movement. I don't know if you can visualize that. So it's about, yeah, you see, this is about a quarter of a turn. And this is of course the most linear region of the readout. I don't dare to touch anything here because just a little bit too much force on super fragile parts like that could potentially damage anything. But you could probably see the fonts down there if I go, yeah, like that. Now you can see the numbers. So that is how it works. On a little disc like that. Wow, I totally love it. It is really, really beautiful. And here is where the adjustment screw touches here on the top. So there's a tiny little mark. But I think I'll just try and assemble this as careful as I can, and hopefully it's still going to align. If not, I know what to do with the alignment here. I really need to show you guys this. And of course I needed to talk about the period measurement. So this is very useful if you're measuring low frequencies. So what I got here is a 10 Hertz signal, and now I want to measure my 10 Hertz, right? So if I do it in frequency mode, 10 Hertz is going to be like that, right? Of course I can go up in 10 seconds a gate time, and over 10 seconds I can count how many pulses I am receiving over 10 seconds. And what you saw here, that is of course 100, so that is 10.0 Hertz. But of course that takes, as you can see, quite a lot of time. But how about we go to the period timer? So what is happening now is it is actually the opposite way. So the 10 hertz input is now a gate that is opening to count for an internal oscillator that now is fed to all the counters, and that is a 1 microsecond pulse that goes to the counter. So for the time that the 10 hertz signal is, we now count with 1 microsecond fast pulses. So look at the resolution I get and the kind of speed in update I get. It is just absolutely amazing, and that is what the period system is always used for. Low frequencies, but again, super high resolutions, and it is super accurate. Of course, it goes the other way around, by the way. So if you go, here it's just for fun, let's just take 10 microseconds. So if I change my input frequency instead of 1, this is 10 hertz, okay? So if I go to 1 hertz instead, right? See what's happening? Now we're counting for a whole second, and then we get a higher number, right? So that is just how it is. We can also go 100 hertz like that. And then we of course get a much lower number. Look at that. Now it goes super fast. We can't even see the... It's probably also going blanking, yes. I'm just totally in love with this machine. That is absolutely a fantastic counter. So I think I'm done playing with this unit for now. There's only one last thing to do, and that is to test the maximum frequency. I kind of always think that is a lot of fun to do. So what I've done here is I take the frequency in times 10. So that means this is 1 megahertz. And here is what I believe is the fastest I can go, 1.4 megahertz. And if I go to 1.5, let's see what happens. Yeah, you see? Then it goes down. And it has nothing to do with the sensitivity or something like that. I can't really... Yeah. This is not changing anything really. But if I go down to 1.4 megahertz, this is intended. I put in 1.4, 5, 6, 7, 8. Just to prove that the unit is actually reading something that is correct. So thank you very much for watching. I hope you had a lot of fun, and please come again soon. All right.